So here I am on a beautiful Friday afternoon, beautiful spring day in Oxford, UK, with Alex Cameron, a postdoctoral researcher in astrophysics, outside the astrophysics building at the University of Oxford. And Alex is a postdoctoral researcher at the university whose specialty is cosmology at the greatest distances. And there was just an interesting conference, which unfortunately I missed here at the university, hosted by the university, on the earliest observations of the Webb telescopes, NASA's James Webb Space Telescope's observations of the earliest galaxies ever detected in the cosmos. And you basically discussed everything about these observations yet known. I mean, JWST is just a relatively new observatory, but it's amazing what you've already gleaned from it, Alex. Can you tell us what surprised you most about about Webb's early observations?
I think what's probably surprised me most so far is so the fantastic thing about JWST is that it's allowing us to really probe in quite a bit more detail the physical properties in a lot of these early galaxies. And so we're really kind of testing what we know about the properties of stars that formed in these very, very early systems in very early phases of the universe. And I think what we're starting to discover is that the way that those stars are enriching the galaxies around them with chemical elements, the way that those stars are shining ionizing photons into the gas around them and heating that up, which causes that gas to glow and emit a lot of light. The signatures that we're getting from these observations are telling us that there's a lot that we don't understand about the properties of these very early stars. And so I think there's been quite a number of surprises, and that's really sort of setting the challenges that we're working on now in trying to better understand what's going on in these early galaxies.
And the interesting thing is these galaxies keep pushing back the look back time. And these are bright galaxies. They're relatively mature galaxies. They're not as big as our Milky Way, correct? I mean, not in this in angular size, but does it surprise you that these galaxies could be so mature, so large, and so well developed so early in the 200 or 300 million years after the Big Bang?
Yeah, so certainly that has been, one of the really big surprises is just how many galaxies we're finding at early times that are so bright. We just, everywhere we look, we're finding a lot of galaxies quite bright, probably brighter than what we were expecting these galaxies to be. And so, the challenge now is to disentangle whether these galaxies are bright because they've got a lot of stars in them, because they've already formed, many, many stars, or whether they're bright because the stars that have formed are brighter than typical stars that we think of in the present day. So ultimately, we would like to know how these galaxies are assembling their mass, what the history of the stars that are forming is, when they're forming stars and how many they're forming. But in order to do that, we need to understand, what the properties of the individual stars themselves are, and therefore, how much these unusual brightnesses are just driven by the stars themselves having different properties.
And could you talk about how Webb actually observes these early galaxies, because it has to use near infrared wavelength, correct?
And that's correct. So because these galaxies are so far in the distance, the light has had to travel so far through an expanding universe that it gets stretched or redshifted to longer and longer wavelengths. So to observe what was emitted from those galaxies as visible light, we have to go and observe at infrared wavelengths. And this was really kind of one of the main drivers behind building JWST was to build a really sensitive infrared telescope so that we could study these distant galaxies.
And we still have not detected hints of maybe hints, but we haven't had a definitive detection of a type population 3 star, correct?
That's correct. Nothing conclusive yet. Everywhere in these early galaxies where we've been able to go in and measure whether there are heavier chemical elements, things like oxygen, present, we've always found those heavier elements. So it is a big open question of exactly when did the first stars form? When did those population 3 stars form?
The population 3 stars are the first stars that formed in the
That's correct.
Universe,
So
the very first.
Population 3 stars are the first stars that formed when, all that was available was essentially hydrogen and helium and some trace amounts of lithium.
But you also said that you were surprised at the amount of nitrogen, or that nitrogen would be present at such early times, and the oxygen, obviously. We both are dependent. We're very dependent here on Earth on both nitrogen and oxygen. You can make the argument that we wouldn't be standing here without those two elements. And astrobiologically, it's interesting that these elements are present at the earliest times.
Yeah, so certainly, it wasn't surprising. It hasn't been surprising to find oxygen at very early times. We know that, the primary ways that oxygen forms can happen quite rapidly after a generation of stars formed. We weren't expecting to see nitrogen in quite as high abundances as what we've seen in some of these bright galaxies early on. But exactly what that means for the overall chemical evolution of the universe, of sort of the general galaxy population, we're still trying to untangle, because really this is based off we've identified a subpopulation of a handful of really bright galaxies that are much more nitrogen enriched than we ever expect to see them. And so, there's still work to be done to kind of put that into the broader context and understand what it means more generally.
And your work is projected to continue as long as the JWST. There's some debate about whether the NASA's budget cuts might affect its operations, but the hope is that that your observations and your work with the JWST data will continue. And finally, what are we learning about our own galaxy from these early galaxies?
Yeah, so, the oldest stars in our Milky Way would have formed at some of these very early times, similar to the galaxies that we're observing in the very distant universe with JWST. So, our Milky Way is assembled from, many galaxies and populations of stars that have sort of merged together over billions of years of evolution. So in understanding how these distant galaxies are forming with JWST, it's telling us also the modes in which some of the early stars in our own galaxy would have formed. And so we can use this to kind of, continue to build the bigger picture of how our own galaxy is built up and where we've come from.
So Alex, thanks so much for your time today. Fascinating conversation. And we look forward to hearing your future results in upcoming papers.
Thank you very much.